Today I am going to present how to determine the deflection of pin-jointed truss by unit load method subjected to eccentrical loading. Last class we have discussed the deflection of a truss for symmetrical loading and geometry by unit load method. But in this presentation, I will solve a problem by taking pin-jointed truss of unsymmetrical geometry and subjected to eccentrical loading. These are the procedures for calculating the truss deflection. So these are the steps you have to remember. Already we have discussed in the last class. So first you have to find out the forces in the members due to the applied load and due to the unit load. Then you have to find out the geometry, that is the length of the truss member, and you have to find out the area of the truss member. Then you have to know the modulus of elasticity from the problem. Then you have to find out the displacement of the joint in the direction of unit load. So you know these steps. So calculate the real force in the member of the truss either by method of joints or by method of sections due to externally applied forces. Then you have to find out the force in the member of the truss due to applied unit load at the joint in the horizontal or in the vertical direction where the deflection is required. You have to find out the length of the truss member. This is from the geometry you can find out, and you have to find out the area of truss member, or this is your given in the problem, and the modulus of elasticity of the truss member, this is also given in the problem. Then after knowing these P, K, L, A, E, then you can find out what is the displacement of the joint in the direction of unit load using this formula. Delta is equal to summation of P, K, L divided by A. This is the formula. Using this formula, you can find out what is the deflection at the joint in the direction of unit load. Then coming to one problem, here we will solve one problem. A steel truss of span 15 meter is loaded as shown in figure. The cross-sectional area of each member is such that it is subjected to a stress of 100 Newton by mm square. Find the vertical deflection of joint C. Take E is equal to 200 kilonewton by mm square. So this is a steel truss. This is a steel truss of span 15 meter. This is AB, BC, and CD. So here AB member is 5 meter, BC member 5 meter, and CD member 5 meter. And this is AE member, and this is EF member, and this is ED member, and this is BF member, and this is FC member. And the angle between the AB member and the AE member is 45 degree. And here the angle between CD member and the DF member is also 45 degree. And one eccentrical loading is present at the point B. And this load is present at a distance 5 meter from the support A and 10 meter from the support B. So this is your eccentrical loading is present here. And this is also unsymmetrical truss. So you have to find out what is the vertical deflection at C. So how will you find out the vertical deflection at the point C? You have to apply unit load at the point C. Then you can find out what is the vertical deflection at the point C. So this is the formula. The vertical deflection at C is equal to delta C is equal to summation of PKL divided by A. So these are the steps used to find out the displacement in the truss. So these are the steps you have to remember. So first you have to find out the reaction due to given loading. Then you have to find out the force in the members due to given loading. Then find out the reaction due to unit load applied at C. This is, here you have to apply the unit load and you have to find out what is the reaction at the support A and support D. Then calculate the force in the member due to unit load at the point C. Then find out the length of the truss from the geometry. Then area and modulus of elasticity of the member is known. Find out all the data in a tabular form. Then using deflection equation, determine the deflection at point C. Then using the deflection equation, you can find out what is the deflection at the point C. So this is the deflection formula. The vertical deflection at C is equal to delta C is equal to summation of PKL divided by A, where A is the cross-sectional area of the member and L is the length of the member and P is the force in the member due to given loading, K is the force in the member due to unit load, and E is the modulus of elasticity. So using this formula, you can find out what is the vertical deflection at C. So first, what you have to do? So you have to find out the reaction due to given loading. First, you have to find out the reaction due to given loading. So this is the truss, and this is the angle, and these are the length AB, BC, and CD, and the other length that you can find out from the geometry, because you know this is 5 meters, this is angle 45 degree. So this length, the other length, because this is also given 5 meters. So this length also you can find out from the geometry, and this length is also you have to find out, and this length you have to find out from the geometry, the length. By considering the given loading, you have to find out what is the reaction at A and what is the reaction at D. So let us take the reaction at A is your VA, and take the reaction at D is VD. So you have to find out what is the reaction at A and what is the reaction at D. You know this is the eccentrical loading. So when there is your eccentrical loading, so you have to take the moment about one support. This is the summation of moment about A is equal to 0. And you have to take the another equilibrium equation, the summation of vertical force is equal to 0. So using these two equilibrium equation, you can find out what is the reaction at the support A and support D. So first you take the summation of moment about the support A is equal to 0. Then you take the moment about the support A. So VD into 15 is equal to 10 into 5. So this is your direction, your anti-clockwise, and due to this load, that the moment direction is clockwise about the support A. That is VD into 15 is equal to 150 into 5. Then you know what is the VD. You know what is the VD. So VD is equal to 150 into 5 by 15. So this is equal to 50 kilonewton. So here you got the reaction at the support D is your 50 kilonewton. Then you take the summation of vertical force is equal to 0. So this is the vertical reaction at A, and this is the reaction at D, VA and VD, and this is the downward load present at joint B. So VA plus VD is equal to 150 kilonewton. But you know VD is equal to 50 kilonewton, so you can find out what is VA. So VA is equal to 150 minus 50, so this is equal to 100 kilonewton. So this is the reaction at A, and this is the reaction at D. Then take each joint and draw the free body diagram, then find out the force in the members. Then you have to take the free body diagram of each joint. Joint A, joint E, joint B, then joint C, then joint D or F. You have to take the free body diagram of each joint, and you can find out what is the force in the members due to given loading. So this you can find out, the forces are computed using the method of joints. So here by using the method of joints, we'll find out the force in the members. So first to take the joint A. So you see at joint A, how many members meet? So here this is AB members and this is AE member. At joint A, the members meet AB and AE. But this is the reaction at A, 100 kilonewton. So take the joint A, the free body diagram of joint A, and this is 100 kilonewton reaction at A, and this is the AB member and this is AE member. So you don't know what is the nature of the force in the AB member and AE member. So what you have to do? First you have to assume the nature of the force. So here you assume the nature of the force. AB is your tensile nature, and the AE, the member AE, the nature of the force is your compressive. Assume these two. AB member is your tensile and AE member is compressive. Then you know the equilibrium equation. The first equilibrium equation is your summation of vertical force is equal to 0. So at a joint A, So you have to take two equilibrium equation. One summation of vertical force is equal to 0 and summation of horizontal force is equal to 0. So this is one vertical force and this is one inclined force. So you have to take the component of this inclined force. FAE sin 45 is equal to 100. Then you can find out FAE is equal to 141.42 kilonewton. But here you got the positive. So then your assumed direction is your okay. So you have assumed the force in the member A is your compressive nature, but here you got the positive value. So here the assumed direction of the force is okay. So FA is equal to 141.42 kilonewton compressive. Then take the summation of horizontal force is equal to 0. So here you see this is the member AB. So the force in the member AB is your FAB. So this is tensile nature. And you take this is the inclined force FA. So you take the horizontal component of this force FA cos 45, but this is your right side arrow mark is your this arrow mark right side, and this arrow mark is your left side. So FAB minus FA cos 45 is equal to 0. Then you can find out FA is equal to 141.42 into cos 45 is equal to 100 kilonewton tensile. So here also you got the positive value, so and 100 kilonewton. So the assumed direction is your okay. So this force is your the tensile, this is your 100 kilonewton, and the A force, the force in the member A is your compressive, and this force is your 141.42 kilonewton. Then you go for joint E because you know this force, you know the force in the member A, but you don't know the force in the member EB and EF. You don't know the force in the member EB and EF. So these two force you can find out by considering the joint E. So take this is joint E, and you know this force. You know the force, this one. This is your 141.42 kilonewton. This one. You know this one 141.42 kilonewton. But you don't know this FEF and FEB. The force in the member EF and force in the member EB. So here these two force you have to find out. Here also you have to assume the nature of the force. So what is the nature of the force in the member EF? So this you have to assume this is your compressive, and the nature of the force in the member EB, that you have to assume the nature is your tensile. So this force you assume the tensile, and this force you take compressive. Again you apply the equilibrium equation, that is the summation of vertical force is equal to 0 and summation of horizontal force is equal to 0. So here this is the inclined force, and you know this force. So you have to take the vertical component of this force. This is your 141.42 sin 45, and the arrow mark is your upward direction. So you take this is your positive, and this arrow mark is your downward direction. Take this is your negative. So 141.42 sin 45 minus FEB is equal to 0. Then you can find out what is the force in the member EB. FEB is equal to 100 kilonewton tensile. So the assumed direction is your okay. Then take the summation of horizontal force is equal to 0, and you find out what is the force in the member EF. So here you take, this is the inclined force. So take the horizontal component of this inclined force. This is 141.42, and this angle is 45 degree. So the horizontal component is 141.42 into cos 45 degree, and the arrow mark is towards right, and this force, the arrow mark is towards left. So 141.42 cos 45 minus FEF is equal to 0. 141.42 cos 45 minus FEF is equal to 0. And here FEF is equal to 100 kilonewton, and here also you got the positive value. So the assumed direction is your okay. FEF compressive, so this is your okay. 100 kilonewton compressive. So the force in the member EF is your 100 kilonewton compressive, and force in the member EB is 100 kilonewton tensile. Then coming to another joint B. This is joint B. This is joint B, because at joint A you know these two force, and at joint E you know these two force, but at joint B these two force is your known force, and you have to find out these two force. These two force. This is the load is present at B. So take joint B and find out these two force. This is joint B. So here this force is, this is 100 kilonewton, and this force is also 100 kilonewton, and this is the load present 150 kilonewton, but these two forces are unknown. But these two forces, FBC and FBF, these two forces is your unknown. So you have to find out these two forces at the joint B. So here also you have to assume the nature of the force FBC and FBF. So the nature of the force FBC assume tensile, and the nature of the force FBF assume tensile. Both are tensile. Assume here both the forces are tensile nature. Again, you apply the equilibrium equation, that is the summation of vertical forces are equal to 0 and summation of horizontal forces are equal to 0. So first you apply the summation of vertical forces equal to 0. How many vertical forces are here? So this is 100 kilonewton upward, and this is 150 kilonewton downward. This is the inclined force, and take the vertical component of this inclined force. This is FBF sine 45, upward direction. So 100 plus, so this is FBF sine 45, FBF sine 45, and this force is a downward direction. So this is minus 150. 100 minus 150 plus FBF sine 45 is equal to 0. Then here the FBF is equal to 70.72 kilonewton tensile. Here also you got the positive value, and the assumed direction is your okay. FBF is your tensile nature. Similarly, take the summation of horizontal force is equal to 0. So here this is one horizontal force, this is another horizontal force, and take the horizontal component of this inclined force. So here this is your FBC, and here plus FBF cos 45 minus 100 is equal to 0. FBC plus FBF cos 45, but FBF is equal to 70.72, 70.72 cos 45 minus 100. This is opposite direction, minus 100 is equal to 0. Then FBC is equal to 50 kilonewton tensile. Here also you got the positive value. So the assumed direction of this force is okay. Tensile. So FBC, here you got the 50 kilonewton tensile, and FBF is equal to 70.72 kilonewton tensile. Here you got these two forces. Then coming to joint C, here you take the joint C. This because at joint A you got these two forces, and at the joint E you got these two forces, and at joint B you got these two forces. Then you go to the joint C, then you find out what is the force here and what is the force here, because this is the known force. But here you see, so at joint C, so this is two forces that is in the same straight line. So this is the third force. So the force in the member is equal to 0. The force in the member FC is equal to 0. So at C, this is, so you know this force and you don't know this force. So take the nature of the force FCD is your tensile. Assume the FCD force is your tensile, and this force, because these two forces are in the same line but in opposite direction. So but here the third force which meet at the joint C is equal to 0. So the force in this member is equal to 0. So you can also find out by taking the summation of vertical force is equal to 0. So this is FCF, but here there is no vertical loading. So FCF plus 0 is equal to 0. So FCF is equal to 0. So this is the force, and the value of this force is equal to 0. Then you take the summation of horizontal force at C is equal to 0. This is FCD. Arrow mark is your right side, and this is 50 kilonewton. Arrow mark is your left side. So here FCD minus 50 is equal to 0. Then FCD is equal to 50 kilonewton tensile. So here you got the positive value, and the assumed the direction of force is okay. So this is the FCD is equal to 50 kilonewton tensile. Coming to joint D, this is, take this joint D, and because you know this force and you have to find out this one, because this is the unknown, because you got from joint C you got this the value of this force, but at joint D you can find out the FDF. Here there is one reaction 50 kilonewton, and you know this the force in this member, but you have to find out this one, the force in the member DF. This is joint. So here also you have to take, this is and this is the reaction 50 kilonewton, and you don't know the force in the member DF. So you have to assume the nature of the force DF is your compressive. Then take the summation of vertical force is equal to 0. So here this is the upward force, and take the component of this force in downward direction, vertical direction, FDF sine 45. 50 minus FDF sine 45 is equal to 0. Then FDF is equal to 70.71 kilonewton compression. So this is here also you got the positive value. So the assumed direction of this force is your okay. So the force is compressive nature. So here you got the force in all the members. Then you write here the force in the member AB is tensile nature, and this force is 100 kilonewton, and the force in the member BC is tensile, and here this is 50 kilonewton, and force in the member CD is tensile, this is 50 kilonewton, and force in the member EB tensile, and this is 100 kilonewton, and force in the member BF tensile, and this is 70.72 kilonewton, and force in the member A, this is 141.42, this is compressive, and this is compressive, and this is 141.42 kilonewton, and the force in the member EF compressive, this is 100 kilonewton, and force in the member DF compressive, this is 70.72 kilonewton. These three are the compressive force, and these are the tensile force. The red arrow mark is the tensile force, and the brown arrow mark is the compressive force. Here the note, the arrow mark toward the joint is compressive, and arrow mark away from the joint is tensile. These are the force in the members. When the truss is subjected to the external loading, then you have to find out what is the deflection at the point C. So you have to apply one unit load at the point C. You have to apply unit load 1 kilonewton at the point C, and you have to find out what is the reaction at the support A and what is the reaction at the support D. VA and VD you have to find out by considering the unit load at the point C, 1 kilonewton. Let us take the reaction at A is your VA and reaction at D is VD. So you have to take the moment about the support A, and you have to find out what is the reaction at the support D. Or take the summation of MA is equal to 0, or taking moment about the support A. So VD into 15 meter is equal to 1 into 10 meter. VD into 15 meter is equal to 1 into 10 meter. Then VD is equal to 0.67 kilonewton. Here you got the reaction at D is 0.67 kilonewton. Then you know the another equilibrium equation, the summation of vertical force is equal to 0. Because this is the reaction at A, VA, and the reaction at D, VD. You know this VD, and this is the vertical downward load, 1 kilonewton. So VA plus VD is equal to 1 kilonewton. Then you can find out what is the reaction at A. VA is equal to 1 minus 0.67. So this is equal to 0.33 kilonewton. So here you got by considering the unit load at the point C. So what is the reaction at A and what is the reaction at D? Take each joint and draw free body diagram. Then find out the force in the members using the method of joints. Then again you have to find out what are the forces in the members, in all the members, by considering the unit load at C. Take the free body diagram of joint A, then take the joint E, then take joint B, joint C, then joint F. So this way find out what is the force in the member. So first you take the joint A. Force in the member due to unit loading, take joint A. So at joint A, so this is the reaction, you know, this is the reaction 0.33 kilonewton, and this is the AB member and this is A member. So you have to find out the force in the member AB and force in the member A. force in the member AB, FAB, and force in the member A, FAE. So here also you have to assume what is the nature of the force in the member AB and A. So assume FAB is your tensile and FAE is compressive. Again, you have to apply here the equilibrium equation, that is the summation of vertical force is equal to 0 and summation of horizontal force is equal to 0. So using these two equilibrium equation, you can find out what is the force in the member AB and in the member A. First, you take the summation of vertical force is equal to 0. So this is one vertical force reaction, and you take the vertical component of this inclined force FAE sin 45. 0.33 minus FAE sin 45 is equal to 0. Then FAE is equal to 0.467 kilonewton compressive. Here also you got the positive value, so the assumed direction is your okay, compressive nature. Similarly, take the summation of horizontal force is equal to 0. Here this is one horizontal force, and take the component of this inclined force in the horizontal direction FAE cos 45. This is FAB, arrow mark right side, and this arrow mark is your left side. So FAB minus FAE cos 45 is equal to 0. Then FAB is equal to 0.33 kilonewton, and here the nature of the force is your tensile. Here also you got the positive value, so the nature of the force is tensile, and the assumed direction of the force is okay. Then coming to joint E, so at joint E, so this the force in the member, this one A is you know, this is you know, but you don't know what is the force in the member EF and EB. So you have to find out the force in the member EF and EB. So here also you have to assume the nature of the force in the member EP and EF. So assume the force in the member EB is your tensile, and force in the member EF is compressive. Assume these two. Again, you have to apply the equilibrium equation at joint E. Summation of vertical force is equal to 0 and summation of horizontal force is equal to 0. So first you take the summation of vertical force is equal to 0. Here you see this is one vertical force downward direction, and the component of this force vertically upward direction, the arrow mark. So this is 0.467 kilonewton sin 45, 0.467 sin 45, and this is downward minus FEB is equal to 0. Then find out what is the force in the member EB. FEB is equal to 0.33 kilonewton, and this is tensile. This is, you got here the positive value, so the nature force, this is tensile. Similarly, take the summation of horizontal force is equal to 0. So this is one horizontal force. I take the horizontal component of this inclined force. This is 0.467 cos 45 minus FEF is equal to 0. Then FEF is equal to 0.33 kilonewton, and here also you got the positive value, and the assumed direction is your okay. So the FEF is equal to 0.33 kilonewton compressive. Then coming to the joint B, this one, joint B. So at joint B, you know this force and you know this force, you don't know these two forces. So you have to find out these two forces are joint B. This one. So this force you know, 0.33 kilonewton tensile. This also you know, the 0.33 kilonewton tensile, but you don't know the force in the member BC and force in the member BF. So here also you have to assume the nature of the force in the member BC and BF. So here assume the nature of the force in the member BC is tensile and in the member BF is compressive. Then using the equilibrium equation, summation of vertical force is equal to 0 and summation of horizontal force is equal to 0. You can find out what is the force in the member BC and BF. So first to take the summation of vertical force is equal to 0. So here this is the force in the vertical direction, upward arrow mark, and take the component of this inclined force vertically, FBF sin 45. This is the arrow mark downward direction. So 0.33 minus FBF sin 45 is equal to 0. Then FBF is equal to 0.467 kilonewton. And here you got this is positive value and the assumed direction is okay. So the force in the member BF is 0.467 kilonewton compressive. Similarly, take the summation of horizontal force is equal to 0. Here, this is one horizontal force, arrow mark right side. This is one force, the arrow mark is your left side. Both are tensile. And here, assume this is your compressive and take the horizontal component of this force. FBF cos 45. This is also left side, arrow mark. FBC minus 0.33 minus 0.467 cos 45 is equal to 0. Then FBC is equal to 0.66 kilonewton. And here also the value is your positive you got. So the nature of the force is tensile and the assumed direction of this force is your okay. Then coming to joint C, this one. So at joint C, you know this force. You know this force from this point, but this force you don't know, this force don't know. These two forces are unknown force, but this is the unit load present at C. This is the unit load present at C. These two known and these two unknown. So you can find out these two forces, force in the member CD and force in the member CF. Force in the member CD and force in the member CF. This is the unit load here at C. And this is the force you know, 0.66 kilonewton tensile. So here also you have to apply the equilibrium equation. And you have to find out what is the force in the member CD and in the member CF. And here you have to assume the nature of the force in the member CD is tensile and in the member CF is tensile. Assume both the forces are tensile nature. Then by taking the summation of vertical force is equal to 0, FCF minus 1 is equal to 0 and FCF is equal to 1 kilonewton. FCF is equal to 1 kilonewton and here you got a positive value and the nature of the force is tensile and assumed direction of the force is okay. Similarly, take the summation of horizontal force is equal to 0. Here this is one horizontal force, this is another horizontal force. So this is FCD minus 0.66 is equal to 0 and FCD is equal to 0.66 kilonewton tensile. Because this is positive value you got and the assumed direction is okay, tensile nature. Then take the joint F. So here you know this force and you know this force and you know this force. These three forces you know, only you don't know this one, DF, force in the member DF. So this you can find out from the joint F. Here you see. So at joint F, this force you know 0.33 kilonewton and this force you know 0.467 kilonewton and this is your 1 kilonewton, but you don't know this force. Assume the nature of this force, nature of the force in the member DF is your compressive, this one. Then using the equilibrium equation, I find out what is the force in the member DF. So here you take the summation of horizontal force is equal to 0. Only one equation is sufficient to find out the force in the member DF. This is 0.33 plus 0.467 cos 45 minus FDF cos 45 is equal to 0. And here you got FDF is equal to 0.934 kilonewton, positive value. So the assumed direction of the direction is okay. So FDF is equal to 0.934 kilonewton compressive. The nature of the force in the member DF is equal to 0.934 kilonewton and this is compressive. Then look at this figure. Here you have to show all the force in the members due to the unit loading. So here you got the force in the member A is your 0.467 kilonewton compressive nature and force in the member EF 0.33 kilonewton compressive and force in the member DF 0.934 kilonewton compressive and in the member PF the force 0.467 kilonewton compressive. These four forces are compressive nature. And the force in the member AB 0.33 kilonewton tensile and B 0.33 kilonewton tensile and in the member BC 0.66 kilonewton tensile and in the member CD 0.66 kilonewton tensile and in the member CF 1 kilonewton tensile. These are the red color indicate the tensile force. Then the arrow mark toward the joint is compressive nature and arrow mark away from the joint tensile nature. This is away from the joint and this is toward the joint. So this is compressive and this is the tensile force. force. So these are the forces in the member of a truss due to unit force at C. Then find out the deflection using this table. This column is where indicate the members of a truss, and this is the length of all the members, and this is the P by A. So you know the stress in all the members is given 100 kilonewton by mm square. In the question given, the stress in the member is 100 kilonewton by mm square. This is your given. So, but you got here DF, EF, and AE member. So this is the P. This is the force due to the external applied force, and the stress due to the external applied force is given here. Here given the cross-sectional area of each member is such that it is subjected to stress of 100 Newton by mm square. This is your given. The stress is your given 100 Newton by mm square. So here you got the force. So you can find out what is the area of the truss, because the stress of all the members you are given 100 Newton by mm square. So accordingly, you have to find out what is the area of each member, because you got the force in the member due to the given loading, and you know what is the stress in all the members. This is your 100 Newton by mm square. So accordingly, you have to find out what is the cross-sectional area of each member. So this is the stress is your given, but here you DF, EF, A, these three forces are compressive force. So here you have to take the stress is your P by A is your, you have to take 100 minus 100 minus 100 minus 100, and the stress in all other members, that is AB, BC, CD, BE, BF, CF. So here you take the tensile stress, and these three member is your compressive stress. P by A into 10 to the minus 3 kilonewton by mm square. This is given in Newton by mm square, but you have to convert in kilonewton by mm square. So you have to multiply by 10 to the minus 3 here. Then this is the K, small k, the force in the members due to the unit loading at C. Here also you got AB, BC, CD. This is the force kilonewton for AB, 0.33 kilonewton, for BC, 0.66 kilonewton, for CD, 0.66 kilonewton, and for DF, EF, AE. So you got that is the compressive, so negative minus 0.934 kilonewton, minus 0.33 kilonewton, minus 0.467 kilonewton. And for B, this is tensile 0.33 kilonewton, and for BF minus 0.467 kilonewton. This is also compressive. These four is your compressive. This one, this one, this one, this one, this one. AE, EF, DF, and BF. These are A, EF, DF, and BF. These four members are compressive, and all other are tensile. This is due to the unit loading. But here, due to the external force, so here you got the three compressive member, DF, EF, A. This is DF, EF, and AF. These three compressive members. These three members are your compressive. Take the force, or take the stress is your compressive, negative, because this is the, you know, that is the stress is your given. The stress is your equal to the force by area. No force in all the members. Stress is your equal to force by area. So area is your equal to force by stress. So you can easily find out what is the area for each members. What is the force you got from the analysis? So using that force and the stress is your constant in all the members. So you can find out what is the area of each members. Then after knowing this one, length P by A and K, so find out here this column present the PKL divided by A. So here you multiply this one, length 5000, and here this is P by A and this is the K. So multiply these three and find out what is the value of PKL by A. Similarly, find out for all the members. Find out for all the members PKL by A. Then find out what is the summation of PKL by A for entire truss. Find out what is the summation of PKL divided by A. So this is 2315.43. This is the summation of PKL by A. Then after knowing this summation of PKL by A, then you can find out what is the deflection at the point C. Deflection at C is equal to delta C is equal to 2315.43, this one, divided by the modulus of elasticity. You know the formula, deflection formula is equal to summation of PKL divided by A. But here you got the summation of PKL by A is equal to this value, but you have to divide the modulus of elasticity to this value, then you can find out what is the deflection at the point C. So this is the deflection at the point C. This is equal to 11.58 millimeter. Now you are clear that how to find out the deflection at a point of the truss using the unit load method.